Okay, welcome to day 5. We're going to prove trig identities. So it's very similar to what we did yesterday where we had to use trig identities to simplify expressions. Well, today I'm actually going to tell you what you should get as a final result, except we have to develop the steps, the algebraic steps with the trig summary sheets and other ideas to get to the final result. And actually this is a little bit harder than what we did yesterday. So the idea is that we're going to use things such as we'll use that summary sheet and all those substitutions that we had, multiplying by reciprocals instead of dividing by something, and adding fractions need to have a common denominator when we do that. And our method is always going to be this. We're always going to start with the left-hand side, and we're going to prove it to the right-hand side. So right now, this is our left-hand side, and we'll try to prove that we're getting this right-hand side. So right now, if I want to rewrite this, well, cosecant is just 1 over sine of x. There's really nothing to rewrite here. Sine and cosine is about as easy as you get. What I can do now is distribute. And I get cosine x over sine of x plus sine of x over sine of x. And cosine over sine is cotangent of x plus sine over sine is 1. And I got what I want. It's as easy as that. Now I made the first one to be very simple, but you see the process is that rewriting things, using the summary sheet, and some other rules that we kind of did yesterday. Well, I think we could tell right away that this one's a little bit more complicated than the first one. First thing I'm going to do is split into two fractions. So I split into two fractions. So I have tangent of x over sine of x cosine of x, and I minus, then I have cotangent of x over sine of x cosine of x. And then I'm going to rewrite tangent and cotangent because I really like when things are just in sines and cosines, because maybe things will clean up for me a little bit. Let's see what happens. So this is me rewriting. As you see, this was tangent, and this was cotangent, and I rewrote both of them, and I'm like, wow, I have a fraction inside of a fraction. So I'm going to use the idea of, instead of dividing by sine of x cosine of x, which is what I have here on the bottom, I'm going to multiply by the reciprocal, 1 over sine of x cosine of x. I think that'll make things easier in my life. So this equals sine of x over cosine of x. Instead of dividing it, I'm going to multiply by the reciprocal 1 over sine of x cosine of x minus the same thing over here with the second term, multiply again, 1 over sine of x cosine of x. If I've done this correctly, I see sines cancels, and this one cosine cancels. And now when I rewrite it, I get 1 over cosine squared of x minus 1 over sine squared of x. And I think we know that 1 over cosine is secant, so this is secant squared of x minus 1 over sine is cosecant squared of x, and I get what I wanted. So I look at this denominator, I see 1 minus sine of x. And I look at that summary sheet, and I don't see it. On the summary, it's close, but it's not the same. It says 1 minus sine squared. So 1 minus sine squared is what's on the summary, and that's what I like. How can I get 1 minus sine squared? 1 minus sine squared of x is really equal to, parentheses, 1 minus sine of x times 1 plus sine of x. Just like if I had 1 minus u squared would equal 1 minus u times 1 plus u, or vice versa. So that gives me an idea. There are really parentheses around this, so I'm going to rewrite this problem. Cosine of x, 1 minus sine of x. I'm going to extend this out. If I do something like this, put 1 plus sine of x here, and 1 plus sine of x here, what am I really doing? I'm multiplying by the number 1. And whenever you multiply by the number 1, you do not change the value of anything. I'm not going to rewrite the numerator. I'm just going to do cosine, don't forget your x, like I just did, 1 plus sine of x, over, so now when I distribute this out, I get what I really wanted, that 1 minus sine squared of x. Because that's on that substitution sheet, that summary sheet. That I like. So I rewrite this, I get cosine of x, 1 plus sine of x, over cosine squared of x. That's what I like. Because we talked about this before, one of these cosines cancel out one of these cosines. I get 1 plus sine of x over just 1 cosine of x, not cosine squared any longer. And again, I could do that whole split into two fractions. I get 1 over cosine of x plus sine of x over cosine of x. And if I be really careful, I see that at the end I get, well, 1 over cosine is secant of x, and sine over cosine is tangent of x, and I get exactly what I wanted on the right side of the problem. So I've gone through 3 problems, and you say, well, how do I know how to do a lot of this stuff? Well, a lot of it is that I've been taught how to do this before. I have experience with it. I've seen it done before. And a lot of times I take paths that don't work out, and I've had to redo them. I have enough experience now as a teacher that I know what I should do, but the idea is that I just kind of use all my rules of algebra I've learned through the year. Like basic arithmetic. I have 2 fractions here. To add them, I need a common denominator. There's no other way to add either. If I had 1 over a plus 1 over b, my common denominator would be a times b, or ab, and that means I would have to multiply this first fraction by b and this second fraction by a, and I would get b plus a as the numerator. Well, technically, this is one denominator, here's another denominator, so my common denominator for this example be 1 minus sine of x times 1 plus sine of x, which we just saw is something that we like when they multiply each other. Which means I would have to multiply this first fraction by 1 plus sine of x, and the second fraction by 1 minus sine of x. And I do that, and I get 1 plus sine of x plus 1 minus sine of x as the brand new numerator, because there's only 1's on top. I see these signs cancel, and right now I have 2 over, we just saw in the last problem when we multiply these 2 out, we get 1 minus sine squared of x, which we saw was something that we like, because then this becomes 2 over cosine squared of x, because that's what 1 minus sine squared is off that summary sheet, and we get what we want at the end, where we have 2 secant squared of x, and that's exactly what we were looking for. Okay, so it's a little bit of manipulation, but you know, we see how it goes. Well, for this next problem, maybe my first instinct is to rewrite things as sines and cosines. Maybe that can help me out. So I get that, and I decide, again, I have 2 fractions added together. I need a common denominator. Only way I could add fractions. Well, for this example, multiplying those 2 denominators, my common denominator would be sine of x cosine of x. So I'm going to put that down here as my common denominator. I say to myself, this first fraction, to get to be sine of x, cosine of x, I need to multiply the first fraction by cosine, the second fraction by sine. Cosine times cosine is going to be cosine squared of x, plus sine times sine is going to be sine squared of x. And I hope when you see this numerator, bells and whistles go off, because that is the number one identity of this is equal to 1. 1 over sine of x cosine of x is what I have right now. Well, again, I can split this up into two fractions through multiplication. 1 over cosine times 1 over sine. Okay, that would give me exactly what I have in green. And then I could say, well, 1 over cosine is secant of x times 1 over cosine is cosecant of x. And that's exactly what I wanted at the end. Okay, so even though I tell you what you want in the end, sometimes the path, I think these paths are a little bit more difficult than what we did yesterday. Okay, last problem, I think we're getting there. Well, I see this, tangent squared of x plus 1. I remember that's on that summary sheet. So right now I have tangent squared of x over, this becomes secant squared of x. And then I decide, let me rewrite things with sines and cosines. Well, tangent is sine over cosine. So tangent squared is tangent squared, or is sine squared over cosine squared, divided by, this is going to be 1 over cosine squared of x. And then I remember my rule of I don't like dividing, so I multiply by that reciprocal, and I get sine squared of x over cosine squared of x. And this guy, instead of dividing it, he's going to multiply by the reciprocal, which is cosine squared of x over 1. And then I do see some things cancel out. I see the cosines cancel, and when I'm all done, I get sine squared of x, which is exactly what I was looking for in the end. This last one kind of was a lot easier than some of the other ones in the middle. Okay, thank you for watching.